Hello, today we're going to start talking about proofs and writing our own proofs and things like that. So I just thought I'd start with a video that you guys could watch so that you get some general ideas of what is going to happen, and then we'll do a few in class, and then I'll let you try some for home at home. All right, so to start with, we are going to start with just coming up with some additional information. We did this the other day. We're going to come up with some additional information to find out how to prove these triangles congruent by angle, side, angle. And so looking at this, to prove it by angle, side, angle, that I would need another angle that has an endpoint on the segment, because it is angle, side, angle, so that would be angle A and angle F. For the next one, for side, angle, side, in order for that to be, to prove these triangles congruent by side, angle, side, well, I've got a side and angle, so I would need another side that wraps around it, and so that side would have to be these guys right here, and it would be BC is congruent to DE. All right, now we got another example down here, and I'd like you guys to try them on your own before I continue on with these. And so now that you've had a chance to try them on your own, for side, angle, side, we would need an angle because we've got two sides congruent, so I would need angle Q is congruent to angle S. Oops, that's supposed to be an S, not 8. Sorry. Angle S. And then for side, 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 we would need that MT is congruent to VD. All right, so there we go. Now we're going to start writing some proofs. So here's what they're going to look like. We're going to write them as a two-column proof. We have statements over here. We'll start out by giving you the statements, and then we're going to fill in the reasons. All right, so we know that CD is perpendicular. Remember that upside down T is perpendicular of AB, and D is the midpoint of AB. Typically what happens is in book written proofs, they usually write the given statements as one statement. Usually when I write them, we'll break them apart into different statements. So step one is given, because that's what they wrote up above up here. Step two, AD is congruent to BD, which is these guys here that they marked on the triangles, and I would always recommend that you mark the triangles as you go. And where I get that from is from the previous step right above it that says D is the midpoint of AB. What does it mean to be midpoint? Well, midpoint means middle, the middle point, so that would mean that AD and DB are equal because this guy's D is the middle point. So we write this as definition of midpoint. Because that's what they told us up above, that it was a midpoint, so we're going to use the fact that it was a midpoint to say those two pieces are congruent. So then what you see right here is we have a side congruent to a side, which are these guys right here. So we're working towards trying to get enough information to prove these guys congruent, and so we're going to work our way through this. Step 3 here says angle ADC is a right angle, and BDC is a right angle, and we get that also from our given statement, and that's where this little perpendicular thing comes into play, that we have that the segments are perpendicular to one another. Well, the fact that they're perpendicular means that they make right angles, so by the definition of perpendicular, we can say these guys are congruent. I should have just used the symbol for perpendicular, the upside down T, instead of writing out perpendicular, but I did. So then, why can we say that angle ADC is congruent to angle BDC? Well, this would be an angle that we would get, and that is because, well, either all right angles are congruent, that's the easiest one, all right angles are congruent, that's the easiest one to use, and so therefore we've proven that. And then why is CD congruent to CD? Well, if you notice, these two triangles are separated by this. The two triangles have the same line in common, and so that would be our reflexive property. All right, so you'll notice that along the way here, that once we proved the angles congruent, we said we had some angles congruent, and then we said those two sides. And so I go back up to my drawing and look where the sides and the angles are related to one another for each triangle, and you'll notice that I have a side, an angle, and a side, where the angle is between the two sides for both triangles. So therefore, I can prove these triangles congruent by side, angle, side. Okay? So that's how the proofs are set up when we go ahead and do these guys. I'm going to do one more, and then that'll leave us 2 for class time to work on. All right, so we've got this problem right here. I don't know if this thing's in the way, but if it is, we'll move it over here. And so we are given that AC is congruent to BC, and D is the midpoint of AB. So you'll notice that they're trying to fill in some of it to give you an idea of what's going on. And so I'm going to fill in the given statements first. That's typically what we're going to do. AC is congruent to BC. That's a given statement. And that gives me, if I mark it on my drawing here, AC is congruent to BC, then I can see what's happening up there, and I can see that I have sides in common, congruent sides. Well, my next given statement, because that's what I'm looking at over here, it says given, is that D is the midpoint of AB. Now, we dealt with midpoint in the previous example, and in that previous example, we talked about midpoint breaking it into 2 equal pieces. And so that would be my next logical step that I would go to, is that D is breaking AB into two segments. Just following. I always try to follow the step above with my follow-up one. So what I'm going to say is, using that D as the midpoint of AB, meaning D right here is in the middle, that would mean that this segment would have to be the same as that segment. So AB, it's AD, not AB. AD is congruent to DB. And that would be a pair of sides congruent to one another. And the reason is, by definition of midpoint. All right, and then, well, we can either do this by side, angle, side, because we've got 2 sides. So remember, our choices are side, 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 angle, side, angle, side, angle, and angle, angle, side. Those are our 4 choices to prove these triangles. That's for this line right here, step 5. Well, at this point, I have already taken out, because I've got a pair of sides, 2 pairs of sides, I can't use either of these 2, because they both only have 1 side in them. So I've already got 2 sides. So now, by process of elimination, I got to decide which one of these 2 I'm going to use, whether I'm going to use side, 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 or side, angle, side. So, as I think about this for a minute, if I have to do side, angle, side, then I'd have to be able to prove that angle A is congruent to angle B. I don't have enough information to do that with this drawing right now, and so therefore I can't say that. If I knew something about isosceles triangles, and if I knew that these angles were the same in isosceles triangles, then I could say that we could say that angle A is congruent to angle B, and that would be by the base angles of an isosceles triangle are congruent. Okay, base angles which would then give me an angle, and then on my line down here I could do side, angle, side. So that would be enough. But most of you probably wouldn't see it that way. And again, this is all about how you see it. And so me, if I was doing this and didn't know anything about isosceles triangle, well, the easier plan of attack on this guy is to notice that you have a reflexive side here, and this reflexive side of CD is congruent to itself. So I could say that CD is congruent to CD, which is the most likely way, and which would give me a pair of congruent sides, and so that would be reflexive. A reflexive property. And therefore the triangles would be congruent by side, side, side. You could do it, like I said, these proofs can be done in any way. It's just a matter of how you see it. but we can prove this guy by side, 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 or by side, angle, side. They didn't tell us how to prove it, so therefore we can go about it any way we like. We will continue on with this in class, so I will talk to you guys soon.